I want to challenge you guys now. Okay. I want you spanner looks like this. And there's a nut in here.
So a wrench, the unit for torque is Newton meters.
Yes. Mm-hmm. Or RF, sine of the angle between the two. What's the angle between the two? Sine of 90 is? Good. So we're left with RF. What is R? No.
0.3 meters.
Good. What is F?
100 meters.
So that gives me a torque of 30?
Yep.
Yeah. Now this is the part I want to show you. Work done when it turns through the angle of 45 degrees. Remember, in any of these calculations, we cannot use degrees. What do we have to do? Convert it to radians. So anytime you have a problem like this and you're given an angle in degree and you want to use it for any kind of rotational motion, you have to immediately convert it to radians. And the easiest way to remember it is pi equals 180. Right? So 45 degrees will be what? Pi over 4. You can't, wait, somebody had a question.
Yeah. It's Newton meters for
Oh yeah, right, sorry. Newton meters.
So
Okay, and then work, the definition of work will be what? We just did that. Somebody remind me. What was it?
the integral from 0 to pi or the integral.
And here they tell us torque is a constant over d phi. And they gave us the d phi, which is 45 degrees. And torque, I calculated it to be 30. It'll be 30 times pi by 4. And then you can solve it. 30 divided by 4 will be what?
7.5.
7.5. Work. Oh, and then the units will be joules. Not per second. That would make it power. Just joules. Okay, now this one. This one you guys should be able to do. What do you do first? You make a free body diagram. Oh, and it's a pull force. Sorry. Is it a pull force? It doesn't matter.
Constant force.
Constant force. I'll call it a force. And it's asking me for acceleration. Well, that one's easy. All I have to do is sigma F equals F. This is MA equals F. So I'm looking for A, which is F over M. 5 newtons divided by 5 kilograms gives me 1 meters per second squared. You notice something? I tend to not do this if I can in equations, just because I want to make sure that my answers are dimensionally correct. Okay, part B.
We got a constant force, so I say.
Excellent. I would agree with you. Equations of motion. Kinematics is a fancy word of saying we're going to use equations of motion. Are you done? Is your answer 5 seconds? 2, part B. Okay, good. Guys, the answer for part B is 5 seconds. And how far does it move in this time? Do you have an answer for that? Everybody got the answers? Yes? No one needs help? Ooh, yay! Okay, continuing on. That's the next question. Where do we start? We start writing down and making pictures. Do we have an answer for part A? Okay, what does it say? It says a gun fires 10 2-grams bullets per second with a speed of 500 meters per second. So the first one, it's asking me for momentum, right? What's the definition of momentum? And what's the mass? 0.002 kilograms. So the answer to this should be part B, average force exerted. Okay, now this is interesting. I am looking for F average. And there are 10 bullets in 1 second. We developed a delta P equals impulse formula. And we also said J impulse was equals to F dot dt. So then this means it will be J average divided by dt equals F. And what is J average? It is J average is 10 bullets times its momentum. Momentum for one bullet, which is 10 times 1 for our case. Is going to be 10 kilograms meters per second. Plug that value in here. And what's the delta T? Per second. That means it will be 10 kilograms meters per second divided by 1 second, which gives me F. So that would be 10 kilograms meters per second squared, which can now be rewritten as newtons. That is not a lot of force for the bullet. 10 newtons. Very small force. Okay, part C. If each bullet is in contact with the glass for 1.25 milliseconds, what is the average force exerted on the glass while in contact? So now we're talking about each bullet. Everybody clear on how we did that, right? Okay, I'm just gonna move this out of the way. Okay, so now we're looking at part C. So the average force per bullet. Okay, it will be D J average divided by dt. So for one bullet, what was it? 1 kilogram meters per second squared, correct? How did we find for JV for 10 bullets? We multiplied it with 10. How are we going to find it for one bullet? Right? Divided by what is delta T? What is delta T? 1.25 milliseconds. Millisecond is 10 to the minus 3. 800. Compare this to that. 10 bullets over 1 second versus one bullet over a small delta T. Look at the difference delta T makes. F is a function of time. F e to the ct, power ct. And we are being asked to find what? Velocity as a function of time. and x as a function of time. What do you think we need to do? We know sigma F equals the force applied. What is the force applied in this case? F0 e to the ct. And on this side, it'll be ma, correct? Which means I can rewrite this as m v over dt equals F0 e to the ct. What am I looking for? So that means everything else goes to the other side?
Correct.
So it'll be dv equals F0 over m e ct dt. And I can integrate from, what does it say? It starts from rest. So 0 to some v, and at time t equals 0. So it should be 0 to t. So what's the answer, guys? V equals F0 over m e to the ct divided by c minus e to the 0 divided by c. Does everybody know where the c comes from, right?
Yes.
It's a constant of the integration. Good. Yep. E to the ct minus 1. So our v as a function of time, I don't even have to write v as a function of time anymore, but since the question asked me that, I'm just going to put it there. Now, how will I find x of t? Integrate that function. Done. So v of t is nothing other than dx over dt, which is f0 over mc ect minus 1, which means I can do dx equals f0 over mc ect minus 1 dt, integrate from x equals 0 to some x, and integrate from some 0 to t, should give me x as a function of time equals f0 over mc ect divided by c from 0 to t minus t from 0 to t. Tell me if I mess up somewhere, which is just f0 over mc ect divided by c minus 1 minus t, which I can also simplify and write as mc squared ect minus 1 minus ct. That's a prettier looking equation. I mean, you don't have to get to that, but it just looks prettier.